Hi, good morning, doctor. My name is Nurul Atinya binti Ayuruddin, and my student ID is 24006 and today I will be presenting about digital blood pressure monitor application of first order circuit. So what is first order circuit? A first order circuit typically consists of a resistor and a capacitor which can store and release energy. So there are two main components in the circuit, which is resistor, which used to limit the current flow, and the second one is capacitor, which is used to store electrical charge and affects voltage change over time. So, what is digital blood pressure monitor? Blood pressure monitor are essential devices used to measure the force of blood against the wall of arteries. A digital blood pressure monitor is a modern automated device used for this task, making the process more accessible and accurate for everyday use. So there are four main components in the digital blood pressure monitor, which is the cuff, which is used to inflate around the arm to apply pressure to the arteries, and the second one is pressure sensor, which is used to detect the pressure in the cuff and the change as it deflates, and the third one is microcontroller or the processor, which is used to process the data from the sensor and calculate the blood pressure. And the last one is the display, which is used to show the final systolic and diastolic reading. So how first order circuit works in digital blood pressure monitor? In a digital blood pressure monitor, the pressure sensor often include a first order circuit which help to measure the pressure response over time. So then the pressure sensor converts the mechanical pressure from the cuff into an electrical signal. Then the sensors respond to the pressure is modeled as a first order system, where the capacitor stores the pressure signal and the resistor controls how quickly the sensor responds to change in pressure. So the next one is how first order circuits apply to pressure measurement. So when the cuff inflates, the pressure inside increases, causing a change in voltage across the sensor's capacitor. The RC circuit then processes the signal as the cuff deflates, giving a clear measurement of the systolic and diastolic pressure based on time constant and the voltage changes. So during inflation, the capacitor charges, creating a voltage change that correlates to the increase in pressure. So during the deflation, the capacitor discharges and reflecting the decrease in pressure, and this helps the device to calculate the pressure point. So in a digital blood pressure monitor, a low pass filter is used to smooth out the measurement data obtained from the oscillometric method. So how the low pass filter works? The RC circuit consists of a resistor and capacitor. The resistor limits the current flowing through the circuit while the capacitor stores and releases electrical charge. The time constant of the RC circuit determines the filter's cutoff frequency. So when the oscillation signal from the cuff sensor passes through the low pass filter, frequencies higher than the cutoff frequencies are reduced while the desired frequency which correspond to the oscillation caused by the heartbeat are passed through. The output then the output of the filter is then analyzed to determine the amplitude of the oscillation from which the systolic and diastolic pressure are calculated. So there are two main purposes of the low pass filter. The first one is noise reduction. The raw signal from the sensor includes both low frequency oscillation related to the blood flow and high frequency noise. The low pass filter removes the high frequency noise while allowing the important low frequency oscillation to pass through. So the second purpose is signal smoothing, which is the filter helps smooth the oscillation signal, ensuring that the calculation of the systolic and diastolic pressure is based on accurate and clean data. So there are also two advantages of low pass filtering in blood pressure monitor, which is the first one is to improve the accuracy. By removing the unwanted noise, the filter ensures that only the genuine oscillation which correlate with blood pressure changes are considered. The second one is to have a better signal detection. The smooth signal is easier to process and analyze for the peaks corresponding to systolic and diastolic pressure. So to conclude, digital blood pressure monitor use first order circuit in their pressure sensor to accurately measure blood pressure. These circuits allow for smooth and precise tracking of pressure changes, which is key to obtaining accurate systolic and diastolic readings. First order circuits are simple yet effective in converting mechanical pressure into electrical signal, making the digital blood pressure monitor reliable and efficient tools for health monitoring.